let's do an example with all this. Example. All right, we have the same situation. This doesn't need any introduction. If you watch the videos up till now, you know what's going on here. At least approximately. You know, this is actually a topic that's kind of hard to wrap your head around. Took me a couple tries before I got it, and I remember feeling frustrated with it when I first learned it. But here's an example nonetheless, okay? You know basically what you're looking at here. Let's draw a couple reference lines. Let's see here. Here's the reference line to the central maximum. Here's what we know. We know that the length L is 1.20 meters. That's the distance between the slits and the screen. We also know that D, the distance between the slits, right, this distance here, is that going to show up on the board? Nope. D, right, the distance there, that doesn't look of D either. We're falling apart here. Falling apart right in front of everybody. Let's see. Let's get this right. Distance here is D, right? The distance between the slits is D. That's a small value. Let's see, 0.0300, 3 sig figs here. Not meters, but millimeters. So this is 3/100ths of a millimeter. Can't see that separation with your eyes. Okay, it's just below what we can resolve with our eyes. So that's pretty small. And what we want, we know one more thing. We know that y to the second fringe, bright fringe, is 4.5 centimeters. Okay, that's what we know. That's what we could call this y2. Okay, y sub 2. It's the y distance to the second bright fringe. If it were down here, it would be y negative 3 or whatever. Y0 is equal to 0. That's the central bright fringe. So that's what we know. Okay, and what we're being asked is this. A, we want to know what lambda is equal to. What's the wavelength of light? Okay. Second thing we want to know is the distance between bright fringes. Can you see that? Yes, barely. Distance between bright fringes. So A, let's just do A first. The wavelength. A. We want to know what wavelength is. Well, we know it's a bright fringe, right? We know there's a bright fringe at Y2 is 4.5. Okay. So we've got the rays coming to there. We've got the rays coming to there. Right. We know that is a point of constructive interference. Okay. We know that. We want to know what the wavelength is. So we know that d sine of theta is m lambda. Okay. And we were given the information for m equals 2, right? Y sub 2 is the second bright fringe. So m equals 2. Okay. That's given to us. We can use this information to find the answer. Okay, so d sine theta is 2 lambda. And we're looking for lambda, so lambda is d sine of theta over 2. Right? Again, this is the m equals 2 plus 2. Bright fringe. Well, we know d is given to us free of charge. We don't know theta. We've got to find theta. We can find theta because we have a triangle. Let's see, what's a good color? Maybe orange I haven't used here. this triangle right there. Here's our theta. Listen to all these nice sounds. Wow. That's a triangle. We don't know what theta is. We can't find what sine theta is. All right, so we need to figure out what theta is so we can figure out what sine theta is. Well, theta is not too hard to find. Theta is the inverse tangent, right, of the opposite divided by the adjacent. Opposite is 4.5 centimeters. Actually, I'm going to write that as to find theta, the opposite is 4.5 centimeters, so it's 0.045 meters, divided by L, the adjacent, which is 1.2 meters. And when you do that math, when you find out what theta is equal to, you get theta is 2.1476 degrees. Now, we don't need all those significant figures in the end, but this is not the answer we're looking for. Ultimately, intermediate answers we need to keep significant figures for. We only cut at the end. Don't forget it. You know who I'm talking to. So, I want to keep this long number here for theta. Now we can find sine of theta. You find sine of theta, and you get 0.03747. Okay. Why did we need sine of theta? Because we're looking for lambda. And lambda, we have to know what sine theta is to find lambda. So lambda now we can solve for. Lambda is d, which is 0.03 times 10 to the negative third meters. Right, that's that number right there. Okay. Times sine of theta, which is 0.03747, and I just went off the screen, almost. Divided by 2. So multiply the numbers and divide by 2, and what you get is lambda is equal to 562 nanometers, which is yellow light. Okay, I drew it pink, but 562 562 nanometers is, in real life, yellow light. Okay, yellow light. So I'm going to stop this video, and I'm going to do a really short one. Let's see, we got 8 minutes and 12 seconds. Let's see, am I going to... Yeah, I'll go ahead and finish this off. Okay, this second part off, B. I'm going to do it right in the middle, so I'll try not to, I'll try to be off to the side here so you can read it. B, the distance between two adjacent bright fringes. Okay, it's not too hard to do. The difference between two adjacent bright fringes, delta y, is equal to y2 minus y1. That will tell us the difference between y2 and y1, which is that is the gap between the bright fringe at m equals 2 and the bright fringe at m equals 1. But they're equally spaced. So if we find one separation, we find all of them. Okay? All of these bright fringes are equally spaced. So if I find the distance between number 2 and 1, I have found the distance between all of them. That's going to be equal to, let's see, lambda lambda L over D times 2. This is from the previous formula, right? Minus lambda L over D times 1. That's the difference between y2 and y1. Okay? So when you do that, we know everything. We know lambda, we know L, we know D. When you put those numbers in, you get the difference is 2.25 centimeters. That is the separation between bright fringes. The bright fringes show up and at steps of 2.25 centimeters above the central maximum and also below the central maximum. Every gap, every one is a gap of 2.25 all the way up and down centimeters. They're equally spaced. All right. We just found the gap between numbers 1 and 2, but that's the same as the gap for everybody. Okay? All right then. That's it for this topic. Next, we're going to move on to another mesmerizing topic all about soap bubbles. Stay tuned.